Okay, what's going on out there?
We've got an investigation for you.
2 identical pizzas, 2 identical knives.
But Jessica can cut hers easily. But Thomas can't.
But mine's really hard. You're not pushing down hard enough. I am. I'm pushing as hard as you, but it just won't cut.
Stella, we need science in action to investigate. What's going on?
I'm onto it.
Those knives might look identical, but are they? And what if one was pushing harder than the other? This needs a fair test.
I've devised the perfect mechanism to make sure I push with the same force on both knives.
These masses should help. Their weight, which is the downward force of gravity on them, can be my push. Here goes.
A mass of 1 kilogram means a downward force of 10 newtons pushing on each knife. Not enough to cut through the apples.
Let's add some more 1 kilogram masses. 2 kilograms. That's a force of 20 newtons.
Using masses like this means I can make sure I push with exactly the same force on each knife, so it's a fair test.
So, a force of 70 newtons is enough for this knife to cut the apple.
But the other knife hasn't made much headway. It needs a greater force.
Sure, I know what you're thinking. This knife is blunt. But what do you really mean by that? Why do sharp edges cut easily and blunt ones don't? Let's take a closer look.
In extreme close-up, you can see the cutting edge of a knife isn't totally sharp. It's a very small surface. A sharp knife has a much smaller cutting surface than a blunt one. When you cut, you apply a pushing force to this surface. The larger the surface, the harder you have to push to cut. It's the pressure of the knife on the apple which makes it cut. This pressure depends on both the pushing force and the area of the cutting edge.
I think we need some more evidence. Well,